Awesome. Thank you so much, everyone, for being here. Good afternoon. How's everyone doing? I know it's been a long 2 days. Get some thumbs up, thumbs down of a condition here. Awesome. I'll try to keep my talk pretty short and sweet today. No, it's getting late in the day. First of all, it's a privilege to be here, and thank you, Sean, for putting this on. I'm really excited to share with you what we've been working on here at SingleStore and how we see ourselves contributing to the advancement of commercial agentic AI. So just a little agenda for today. I just want to set some context by talking about the potential of agentic AI and outline the technical capabilities we believe need to be fulfilled in order to realize this technology. Then I just want to share our observations around the complexities of the enterprise data stack and how SingleStore's decade-long of work and future roadmap are built to solve these problems. So first, let's quickly recap why agentic AI has been all the buzz. We've seen in pop culture the potential illustrations of how superintelligence could radically change human lives. Though most of these references are rather dystopian and dark, I am a firm believer that AI will be a much brighter force for good. Today, agency and business processes belong to humans. We as humans drive the process. And here are two common examples of workflows that hopefully many of you can relate to. So the first one is knowledge search. We're currently in a world of answers. We have a question, we run some RAG over a specific data set, and we get an answer. So for example, how does the Digital Services Act in Europe affect our company's content moderation policies and practices if we operate a social media platform or online marketplace in Europe? The second type of analyses that you might do in enterprise is a root cause analysis. Say, for example, your company is currently experiencing a 35% drop in revenue in Asia Pacific. You set some hypotheses and you go produce some analyses in Tableau or Power BI. But ultimately, humans are the ones who control the feeds of that data, and we have to cut and interpret that data to present insights and evaluate our own hypotheses. In the future, hopefully, AI will be the one to drive the process, proactively providing insights to humans for questions we may not even have known to ask. So instead of searching for knowledge, you're served relevant knowledge based on your context, just like a knowledge feed. So for example, an agent might say, the Digital Services Act is currently in EU Council review. This could affect your digital marketing strategies and specifically XYZ campaigns. For our analytics use cases, instead of needing to form hypotheses and then cut the data yourself, you might get preemptive impact analytics being conducted. For example, competitor-wise acquisition of local distributor in Malaysia could decrease our selling volume by 15% across Thailand, Indonesia, and Vietnam due to their ability to access a logistics network through their acquired target. So the question is, what is actually needed to bring about such an agentic AI? Let's start from the user expectations and infer the technical requirements. Some core job competencies of an agentic AI, among many, include constant feed of all sorts of data to develop live context, the ability to instantly relate consumed data to everything that the AI already knows, the ability to remember everything that it's been fed, and the ability to quickly and accurately identify what data is relevant to your current situation. So what does this mean for technical requirements? An agentic AI that must constantly be aware of your context, like Meta AI on MetaQuest, autonomous driving models, requires real-time ingestion of multimodal data. An AI that needs to be able to instantly relate live consumed data to everything it already knows would mean the need to have on-demand embeddings. And for an AI to remember everything that it's been fed, you would virtually need unlimited data storage. Finally, to be able to accurately identify and quickly performantly retrieve the relevant data to your context, the system would need fast queries, search, and potentially even graph query capabilities. These set of technical requirements is what we refer to as dedicated memory and retrieval architecture. We believe this will be a crucial unlock in delivering tailored performance of LLMs in enterprise settings and lead to a more widespread adoption of AI and pave the way for the future of agentic AI in commerce. So the question is, how do we implement this in enterprises? This is going to be a little wild. Most enterprises look like this. Customers might start with an open source DB, be it MySQL, Postgres, which works fine when you have small data sets and a limited number of users. Then you think about wanting to bring in some operational data. It starts to struggle, but you can still add more servers and vertically scale to support it. Then you're thinking about, can we add some third-party data, some JSON semi-structured data? So you now need something like MongoDB. Now, as your number of users grow, or as the data complexity grows, your performance starts to dip. Query latency increases, so you need to add a cache like Redis to speed up the queries, and not to forget, it's very, very costly. Then you're going to think about streaming data from IoT sources, so you need to integrate with Kafka. And then you're also thinking about putting on analytics on top of all of this, so you now have to add something like a Snowflake, a ClickHouse, a Druid, or a StarRox. And on top of all this, you may even need to do some full text search for Elastic, or integrate with Pinecone for vector search. As you can see, this is an incredibly complex matrix to optimize and feed your data in real time to an LLM. You're stitching together multiple databases, data engines, and components. You have to manage multiple systems, you're moving data, replicating data, and then loading it again. And it starts to impact the performance, and now you're introducing copious overhead to maintain all these working systems, not to mention the number of people that you would potentially have to hire to maintain all this. So how is anyone supposed to feed all this to an LLM? Even more so, how do you add a dedicated memory and retrieval architecture? In reality, the data your models need don't live in a vector store. And this is just for retrieval. If you want to utilize all your real-time data, it gets even more complex. So wouldn't it be nice if you had a single place to store all your data? Then from this single source, your LLM retrieves, saves its LLM states, optimizes inference, and fine-tunes from this single source. This is why we built SingleStore. One store for all your data, and one source for your LLM's memory and retrieval. SingleStore today is the result of over a decade of research-driven innovation and development. This was not an overnight success. It's pretty difficult to disrupt a 50-year-old database business with many, many players. Since our founders started the company in 2011 as MemSQL, SingleStore has built a one-of-a-kind OLTP and OLAP database that serves mission-critical applications for over 350 enterprise customers and generates more than 100 million ARR. We have invested heavily in research-driven innovation to develop the technical advantages that make SingleStore the most performant all-in-one database. One of our historical strengths is having native data integration services. These pipelines allow for quick ingestion of data from an enterprise's various sources. This includes parallelized high-throughput ingestion, CDC in, CDC out, native integration with lakehouse formats, including Iceberg, all while being AST compliant. Second is our petabyte-scale storage. We have separated storage and compute to get bottomless, allowing for independent scaling of storage and compute most efficiently to meet the needs of dynamically changing workloads. We have extra durability coming from all data eventually landing in blob storage, achieving an effective always-on continuous backup, disaster recovery, and point-in-time recovery as well. Third is our support for high concurrency and unrivaled speed in query performance on multiple data formats. We have millisecond query performance on multiple formats and millisecond aggregations on complex queries involving complex joins, filters, and aggregates, achieving unrivaled analytical and retrieval performance on your data. So today, we actually have most of the pieces to deliver on dedicated memory and retrieval. In our upcoming release, we will be completing the arsenal. First of all, we will be introducing native embeddings in engine on demand. We've pushed down embedding capabilities to our query engine and allow for users to create embeddings on the fly. Via various methods, including SQL language or in a pipeline in a notebook, we will enable you to generate embeddings with your choice of model live upon ingest and query and perform queries directly on those embeddings. Thus, instead of constantly needing to embed everything and wait for API calls, you can do it in batches, speeding up your time to first token. As I'm sure many of you have also seen from other talks at this conference, like Neo4j, graph capabilities are also potentially a key unlock. With the help of our partners at PuppyGraph, we are also pleased to announce that we can now offer out-of-the-box graph query capabilities directly on your existing data in SingleStore without the need for ETL. So now if you want to do a 10-hop, a shortest path, or some other very complex query better solved using graph, you can now do so out of the box with no changes. In addition to the core functionality for delivering dedicated memory and retrieval for LLMs, we have a suite of features that we have built to enable secure and productive collaboration on SingleStore within enterprises. You'll see many companies you know here, and we serve some of the world's largest technology companies, banks, retailers, and manufacturers to power their most mission-critical data infrastructure. We also have some of the fastest growing disruptors of their industries as well. If the idea of having dedicated memory and retrieval architecture for LLMs excites you, please feel free to reach out, and we'd love to hear from you and partner with you to prototype, design, and continue building towards an exciting future with AI. And with that, thank you everyone for taking the time.
Oh, thank you to our speaker. We have time for, about 5 more minutes, so if anybody would like to ask a question, I will try to get the microphone to you. Okay, I don't see any, so thank you. How can we find out more about it? Are you in the booth area?
Yeah, you can come visit our booth downstairs. I actually don't quite know our booth number, but it is right next to the Microsoft one where the coffee is.